This is my book on Amazon, probably Coins, Dice, and Cards by Carlo. It is a book about learning probability through examples with coins, dice, and cards. So this is a brief intro into the book. I'm going to read parts of the book and hopefully you're interested in reading further. It sells as a paperback and as an ebook and is also available on Kindle Unlimited. First, we have to know the rules of probability in statistics. We often refer to a probability as the chance of something occurring. A 100% chance is a 1 probability. A 0% chance is a 0 probability. And, for instance, a 50% chance is a 0.5 probability. A 3.7% chance is a 0.037 probability. So we often refer to probabilities instead of percentages because it's easier to calculate things. Probability is a probability of event A occurring. A probability is between 0 and 1 inclusive. It could be equal to 0, it could be equal to 1. Probability of some event A is the number of outcomes satisfying A divided by the total number of outcomes. Probability not A is 1 minus probability of A. For instance, if it rains with probability 0.7, the probability it doesn't rain is 1 minus 0.7, which is 0.3. Then we have the general addition rule. Probability A or B is probability A plus the probability of B minus the probability of A and B. And in general, if the A and B don't overlap, we can say that probability A and B is A or B is just the probability of A plus the probability of B. Another rule that we're going to look at throughout the book is the independence rule for probability A and B. When it's and, you multiply. So probability A and B is probability A times probability B. This is not always possible if you don't know the conditional probability of B given A, that A has already occurred. But usually we can multiply these probabilities together. So just remember, or A plus B, probability A plus probability B, and probability A times probability of B. Let's talk about tossing coins. This is a common experiment in statistics. When you have two coins, it's just heads or tails, we can represent that as H or T. And we just have 50% of heads, 50% of tails. If we toss two coins, well, the outcomes are heads and tails, first toss, second toss, tails, heads, tails, tails, and heads, heads. So there's a lot of examples with tossing 3 coins and tossing 4 coins in this book. I'll let you look at that further if you decide to purchase the book. Next, we can go to rolling dice. This is a common statistical experiment used in probability courses. When we talk about a fair 6-sided die, if we roll that one time, probably roll a 1 equals a probably roll a 2 equals probably roll a 3, 4, 5, 6. They're all 1/6 probability because the probability roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6 is a 1 probability, 100% chance you either roll 1, 2, 3, 4, 5, or 6. The sample space is all possible outcomes, 1, 2, 3, 4, 5, 6. When we roll 2 dice, we can come up with a chart for all the possible outcomes when rolling 2 dice. There are 36 possible outcomes. And the outcomes go as follows. You have 1, 2, 3, 4, 5, 6 on both dice. So for instance, this chart, you get a 1 and a 1, you get a 2 total. 1 and a 2 on the second die, you get a 3 total. 1 and a 3 on the second die, you get a 4 total. If you get a 2 and a 1, you have a total of 3. 2 and a 2, total of 4. For instance, you get a 5 on the first die and a 4 on the second die. The sum is 9. So when we try to evaluate the sums, we just look at all the outcomes that sum to a certain number divided by 36 possible outcomes. And we can represent this as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, etc., all the way to 6 and 6. So let's look at some examples. Let's look on the next page, another diagram. Actually, let's go back to this page. What is the probability you roll a sum of 9? The first thing we can do is look at the chart for the sum of 2 dice and all the pairs of dice that sum to 9. So for instance, we see on this chart, the sum of 2 dice chart, that there are 4 possibilities where the sum is 9, and there's 36 possibilities overall. So probably roll of sum of 9 is 4 out of 36. There's a 3 and a 6 sums to 9, a 6 and a 3 sums to 9, a 4 and a 5 sums to 9, and a 5 and a 4 sums to 9. So that's 4 possible equally likely outcomes out of 36. Okay, so I'll let you read further for the dice. And there's another chart on this page, 9, 10, 11, or 12 sum, 9 or greater sum with 2 dice. Okay, what about cards? Well, with cards, you have basically there's 4 suits with 13 cards for each suit. There are clubs, spades, hearts, and diamonds. There are 2 colors with 26 cards of each color, red and black. 26 red cards, 26 black cards. There are 4 of each card type. Aces, kings, queens, jacks, 10s, 9s, 8s, all the way to 2s. And there are 1 of each card type and suit combination, ace of clubs, ace of diamonds, etc. Okay, so let's go to the next page. We can see none of the suits overlap, so the probability you get when you draw 1 card, you cannot get a card that is both spades and clubs, or both spades and diamonds, or both diamonds and hearts, etc. These suits are mutually exclusive. Probably clubs and hearts is 0, right? And you can't get 2 cards of a card that is of different suits. So that's mutual exclusive. So if we look at this example here, what's the probability of getting an ace or a king? Well, if we draw the chart, probably ace or a king is probably ace plus probably king. They're mutually exclusive. An ace, a card that's an ace, it cannot be a king. So it's just 4 out of 52 plus 4 out of 52. Probably A or B is probably A plus probably B. 4 out of 52 plus 4 out of 52 is 8 out of 52. Okay, that's at the top here, 8 out of 52. And there's some other examples for probably king or clubs, probably queen or black card. And I'll let you look at those examples if you decide to purchase the book. What about probability of getting 3 aces in a row? Well, if there's a probably ace on the first draw, it's 4 out of 52. There are 4 aces out of 52 cards overall. And then if you already got an ace on the first draw, there's 1 less ace, so it's 3 out of 51. You multiply those together. Probably ace on the third draw, you draw 2 aces, so there's 4 minus 2, which is 2 aces left, and there's 50 cards left, so it's 4 out of 52 times 3 out of 51 times 2 out of 50. What if we want to find the probability of drawing a flush? To draw a flush of hearts, that means that all the cards you draw must be hearts, okay? With a 5-card poker hand, how would we figure this out? Well, there's 13 hearts. On the first draw, there's 13 hearts, and there's 52 cards. So it's 13 out of 52 that you draw a heart on the first card, which is basically 1/4. Then if you drew a heart on the first draw, on the second draw, there's 12 hearts left, and there's 51 cards overall left because you drew 1 card. Without replacement means you don't put the card back in the deck. Okay? 12 out of 51, and there's 11 hearts left out of 50, 10 hearts left out of 49 on the fourth draw because you drew 3 hearts already, and then you drew 4 hearts. There's 13 minus 4, which is 9 hearts left on the fifth draw, and 48 cards, 52 minus 5, 52 minus 5, 4. It's the fifth draw. So now we have multiply all these together, and there's about a 1 in 2020 chance of being dealt a flush of hearts. Now, if you want to find the probability of a royal flush, that's another calculation that you can look at. And this book also tells you the chances of getting 21 points in a game of blackjack. And there's also a bonus problem at the end of the book for drawing balls from an urn. It's a common statistical experiment that we talk about. So if you're interested in reading this further in this book, I recommend that you go on Amazon and purchase the book. Remember, it's called Probably Coins, Dice, Cards by Carlo. It sells for $10 as a paperback and $3.99 as an ebook. So I hope you enjoyed this presentation, and thanks for paying attention to my presentation. Okay, thank you very much.